Hi there, welcome to Ancient Cosmos Sleep. Tonight we float quietly above a universe that is still young enough to surprise itself. Around you, darkness is not empty. It shimmers with invisible rivers of matter, immense clouds of gas, and the faint glow of the first generations of stars. Far below, if directions even mean anything on these scales, enormous structures are beginning to gather. Tiny fluctuations left behind from the earliest moments after the Big Bang are slowly growing into something extraordinary. And somewhere in that growing cosmic web, the story of a galaxy begins. The funny thing is that when you imagine a galaxy dying, you might picture a sudden catastrophe. Perhaps a gigantic explosion, perhaps a cosmic collapse. Something dramatic enough to earn a soundtrack and a slow-motion montage. The universe, however, prefers paperwork. Galaxy death is usually a process so slow that entire civilizations could rise, vanish, be forgotten, and become archaeological mysteries millions of times over before the galaxy notices anything has changed. You probably won't survive this. To be fair, neither will the Sun, Earth, or that mysterious charger cable you've been keeping in a drawer for years, because it might be useful someday. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're settling in, feel free to share your location and local time in the comments. It's always fascinating to see where in the world fellow night travelers are listening from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift closer to one of the first great gathering places of matter. The universe is only a fraction of its current age. Vast clouds of hydrogen and helium stretch across millions of light years. Gravity, patient as ever, begins pulling these materials together. A mainstream scientific fact often surprises people. Galaxies did not appear fully formed. They grew gradually through mergers, gas accretion, and gravitational attraction over billions of years. At first, what will become a galaxy resembles a messy construction site rather than a magnificent spiral. Clouds collide. Gas heats up. Matter falls inward. If you could watch at high speed, the scene would resemble cream swirling through coffee. Only the coffee is millions of light years wide and significantly harder to clean from the carpet. As matter gathers, the first generations of stars ignite. These ancient stars are different from many stars you see today. The universe at this stage contains almost no heavy elements, no oxygen, no iron, no carbon-rich worlds waiting to host curious creatures. Just enormous stars burning hot and fast. Some astronomers believe many of these first stars were hundreds of times more massive than the Sun. They blazed brilliantly before dying relatively quickly, enriching the cosmos with heavier elements. Without those early stars, neither planets nor people would eventually exist. You owe your atoms to stellar recycling programs that began billions of years before Earth appeared. Quite an impressive family tree. As the galaxy grows, dark matter quietly shapes its future. Dark matter remains one of the great mysteries of modern astronomy. Scientists know it exists because galaxies rotate in ways that visible matter alone cannot explain. Something unseen provides extra gravity. You cannot see it, you cannot touch it, you cannot order it online. Yet it appears to outweigh ordinary matter by a considerable margin. The galaxy forms within a vast halo of this invisible substance. Like a city built upon foundations nobody can directly observe, there is even a quirky tidbit associated with dark matter. Over the decades, researchers have proposed all sorts of candidates to explain it, including hypothetical particles with names that sound suspiciously like rejected superhero characters, actions wimps, machos. Somewhere a marketing department would be very proud. As centuries become millennia and millennia become millions of years, the galaxy grows more organized, gas settles into rotating structures. Stars arrange themselves into disks, clusters emerge, nebulae glow. What began as scattered matter slowly develops identity. This process mirrors something surprisingly familiar. Imagine a city. At first there are only roads and empty land, then buildings appear. Neighborhoods form, traffic becomes unavoidable. Eventually, the city develops a character all its own. Galaxies follow a similar pattern, though their traffic jams involve stars moving at hundreds of kilometers per second. During this era, the galaxy is very much alive. New stars are constantly being born. Bright blue giants illuminate spiral arms. The dense molecular clouds serve as stellar nurseries. The galaxy shines with youthful energy. If galaxies had social media profiles, this would be the stage featuring vacation photos, ambitious goals, and captions about living life to the fullest. The aging process has not yet begun, or at least it is difficult to notice. The remarkable thing about galaxies is that their deaths are often determined during these early years. Every star born consumes fuel. Every burst of star formation depletes reservoirs of gas. Every merger changes the future balance of the system. A galaxy's destiny is quietly accumulating long before anyone would recognize signs of decline. Historians still argue whether certain ancient civilizations fully understood the true nature of the Milky Way. Across cultures, people looked upward and interpreted that glowing band of light in many ways. Rivers of souls, celestial roads, divine pathways, or cosmic oceans. None of them knew they lived inside a galaxy, and honestly, it would have sounded rather unbelievable. You are standing on a rocky world orbiting a medium-sized star, inside a rotating collection of hundreds of billions of stars, itself moving through a universe containing trillions of galaxies, not exactly an elevator pitch. The young galaxy continues growing, more stars appear, more clusters emerge. Gravity sculpts elegant structures from apparent chaos. From your drifting vantage point, the galaxy seems eternal. Nothing about it suggests mortality. Nothing hints that one day its brilliant spiral arms may fade. Nothing reveals that the very processes creating beauty now are also laying foundations for eventual decline. That is the strange truth about galaxies. Their deaths begin with their births. Every new star consumes a little more of the future. Every shining region spends resources that cannot easily be replaced. Yet there is no tragedy in this, only transformation. The universe rarely destroys things outright. Instead, it changes them slowly, patiently, almost gently. And as you continue drifting beside this growing island of stars, watching billions of suns ignite across cosmic time, the galaxy enters its most vibrant age, a period when creation vastly outweighs decline, and when the long road toward death remains hidden beneath the brilliance of life itself. The galaxy settles into a rhythm, not the kind of rhythm marked by clocks, calendars, or the gentle ticking of seconds, but one measured in millions of years. Entire mountain ranges on Earth could rise and erode away before the galaxy completes what it considers a small adjustment. You continue drifting through this immense stellar city as it enters the longest and most productive phase of its existence. The construction boom is still underway. Everywhere you look, stars are being born. Massive clouds of cold hydrogen drift through the spiral arms. Gravity compresses pockets of gas until temperatures rise high enough for nuclear fusion to ignite. A new star awakens, pushing back the darkness with fresh light. Then another forms, and another, and another. The galaxy resembles a cosmic garden in perpetual bloom. A mainstream scientific fact is that galaxies like the Milky Way can create several new stars every year during active periods of star formation. That may not sound impressive at first, but remember that this process continues for billions of years. The result is a population of hundreds of billions of stars. Quite a productive hobby. You watch as clusters of brilliant blue stars illuminate nearby clouds. These stars are youthful, energetic, and somewhat reckless. Astronomically speaking, the biggest stars are terrible at long-term planning. A star 10 times more massive than the Sun burns through its fuel dramatically faster. It's the cosmic equivalent of spending your entire paycheck 5 minutes after receiving it, and then acting surprised. The galaxy doesn't mind. There is still plenty of material available. Cold gas continues flowing inward from surrounding space. Dark matter halos guide the movement of matter. Fresh fuel arrives regularly. For now, the future appears limitless. As billions of years pass beneath your watchful gaze, the galaxy develops structure and personality. Its spiral arms become more pronounced. Star clusters orbit the galactic center. Nebulae glow with shades of pink, blue, and violet. Dust lanes wind gracefully through the disk. The galaxy becomes recognizable. If you could take a family portrait of the universe, this would be the stage where the galaxy smiles confidently for the camera. Deep within the core, however, another player is quietly growing: the central black hole. Nearly every large galaxy appears to host a supermassive black hole at its center. Some contain millions of times the Sun's mass. Others contain billions. At the moment, this black hole remains relatively calm. It feeds occasionally on nearby matter, but does not yet dominate the galaxy's story. Like a sleeping dragon beneath a prosperous kingdom, it waits. You continue moving through regions packed with newborn stars. The light is astonishing. Disk and stellar associations shine so brightly that entire sections of the galaxy appear illuminated from within. Some stars possess planetary systems, others travel alone. Some are surrounded by disks of dust that may one day become worlds. Perhaps somewhere among them, life emerges. Perhaps countless civilizations gaze upward from distant planets, wondering about their place in the cosmos. Perhaps some are inventing astronomy. Others are inventing taxis. Civilization truly contains multitudes. One particularly fascinating fact from human history comes to mind. In 1924, astronomer Edwin Hubble demonstrated that the Great Spiral Nebula in Andromeda was actually a separate galaxy beyond the Milky Way. Before that discovery, many people believed the Milky Way might be the entire universe. The realization that countless galaxies existed beyond our own dramatically expanded humanity's understanding of reality. Imagine discovering your hometown is not the entire planet. Then discovering the planet is not the entire solar system. Then discovering the solar system is not even remotely special. Astronomy has a talent for humility. The galaxy continues thriving. Its star-forming regions pulse with activity. Shockwaves from exploding stars compress nearby gas clouds, triggering new rounds of stellar birth. Creation leads to creation. Generalization follows generation. Matter cycles continuously. A quirky tidbit from astronomical history adds a touch of charm here. During the 20th century, some scientists jokingly referred to certain star-forming regions as cosmic maternity wards because new stars seemed to emerge. Everywhere researchers looked. The nickname never became formal scientific terminology, probably because maternity ward sounds less intimidating in research papers. Still, the image remains delightful. You glide through one enormous molecular cloud, stretching hundreds of light years across. Within its cold darkness, future stars wait. The cloud appears peaceful from a distance. Yet inside, gravity is conducting a slow and relentless campaign. Tiny density differences grow larger, gas gathers, pressure increases. Future suns begin taking shape. The galaxy remains healthy because these clouds still exist in abundance. They are its reserves, its fuel tanks, its savings account. And like any savings account, eventually withdrawals become larger than deposits. But that problem lies far ahead. For now, abundance reigns. Historians still argue whether some ancient skywatchers recognized subtle details within the Milky Way visible to the naked eye. Records from different civilizations suggest remarkably careful observations. though exactly how much they understood remains debated. Regardless of interpretation, those observers shared something with you. Wonder. That same wonder fills the galaxy's bright age. Everywhere there is motion, stars orbit the center, gas flows through spiral arms, clusters drift along vast gravitational pathways. Nothing stands still. Yet beneath all this activity, an invisible clock continues ticking. Every new star consumes hydrogen. Every stellar nursery uses raw material. Every brilliant blue giant shortens the supply. The galaxy remains wealthy, but it is no longer gaining resources as quickly as before. The change is subtle, almost impossible to detect. Imagine watching a tree grow. For years it appears larger and stronger. Only much later do you notice that growth has slowed. The galaxy experiences something similar. No dramatic announcement arrives, no cosmic memo appears, no giant sign flashes across the spiral arms reading, "Warning. Fuel concentration exceeding replenishment." The universe rarely provides such conveniences. Instead, the signs remain hidden within statistics. Star formation rates decline ever so slightly. Gas reservoirs shrink by tiny fractions. Future generations inherit a little less than previous ones. Nothing alarming, nothing urgent. Just the first whispers of aging. Yet from your perspective, floating through billions of years, the pattern becomes visible. The galaxy's golden age cannot last forever. Its beauty depends on continuous creation. Its brightness depends on fresh stars. Its vitality depends on supplies that are ultimately finite. Still, the galaxy shines magnificently. Spiral arms sparkle with blue giants. Clusters glitter like scattered diamonds. Nebulae glow across enormous distances. If anyone living inside this galaxy could witness the entire structure from outside, they would probably assume it will endure forever. Most things seem eternal while they are flourishing. The future decline remains hidden behind overwhelming success. And so the galaxy continues through its glorious middle years, creating stars by the billions, illuminating the darkness with extraordinary abundance, unaware, or perhaps unconcerned, that every brilliant birth is quietly bringing the distant end a little closer. The first signs are easy to miss. You drift above the galaxy as billions of years continue slipping past like grains of sand through invisible fingers. At a glance, everything still appears healthy. Spiral arms remain bright. Stars continue forming. Nebulae still glow softly across the galactic disk. Nothing looks wrong. And yet something has changed. The galaxy is beginning to run low on its most precious resource. Cold gas, not stars, not planets, not black holes. Cold hydrogen gas. Without it, new stars cannot form. Without new stars, the galaxy slowly loses the ability to renew itself. The process resembles a vast city whose factories are quietly receiving fewer deliveries each year. The lights remain on. The streets remain crowded. Business continues as usual, but somewhere deep within the supply chain, shortages have begun. A mainstream scientific fact is that star formation depends heavily on dense molecular clouds composed largely of hydrogen. As galaxies age, these reserves can become depleted, heated, or stripped away, reducing their ability to create new stars. You watch as enormous stellar nurseries that once bustled with activity begin producing fewer newborn suns. The difference is subtle. One cloud forms 10,000 stars instead of 12,000. Another produces thousands rather than tens of thousands. No individual observer notices. But over immense stretches of time, the trend becomes impossible to ignore. The galaxy is spending more than it earns. Cosmically speaking, retirement planning has arrived. Unfortunately, galaxies never attend financial seminars. You move through one of the great spiral arms. Billions of stars still shine around you. Bright blue giants continue illuminating the surrounding gas. Yet gaps are appearing. Regions that once produced stars continuously now remain quiet for longer periods. Cold clouds disperse without giving birth to large stellar populations. The galaxy is still alive, very much alive, but it is no longer young. The reasons vary. Some gas has already been transformed into stars. Some has been blown away by powerful stellar winds. Some has been heated until it can no longer collapse efficiently into new stellar systems. Some has simply become difficult to access. The result remains the same: less fuel, fewer births, slower renewal. You pass near a cluster of massive stars nearing the ends of their lives. These giants burn with astonishing intensity. Their radiation sculpts nearby clouds, their stellar winds push material outward. Eventually, some will explode as supernovae. Ironically, the stars that help create future generations can also disrupt future star formation by scattering and heating surrounding gas. The universe enjoys complicated relationships. Nothing is ever entirely helpful or entirely harmful. One generation influences the next. The cycle continues for now. As you travel onward, you notice entire regions of the galaxy taking on a slightly different appearance. The brightest blue stars become less common. These stars live fast and die young. When star formation slows, their absence becomes increasingly noticeable. Blue stars are like energetic party guests who arrive loudly and leave early. When fewer new guests arrive, the room gradually becomes quieter. The older stars remain, the younger stars become rarer. The atmosphere changes. A quirky astronomical tidbit emerges from this transition. Some astronomers refer to galaxies that have largely stopped forming stars as red and dead. It sounds slightly rude. Imagine spending 10 billion years constructing hundreds of billions of stars only to receive a nickname that resembles a failed tomato. Yet the description captures an important reality. Older stars tend to appear redder. As young blue stars disappear, the overall color of the galaxy shifts. You continue drifting through vast distances. The galaxy's center remains active. Stars orbit steadily. Dark matter continues providing gravitational support. Nothing dramatic occurs. That is perhaps the strangest aspect of galactic aging. The decline is astonishingly gentle. No alarms. No explosions large enough to announce the beginning of the end. No cosmic narrator appears. The galaxy simply becomes less productive, less energetic, less capable of renewal. Historians still argue whether certain ancient cultures interpreted the fading appearance of celestial objects as signs of cosmic aging or divine messages. The surviving records often leave room for multiple interpretations, and scholars continue debating exactly what many observers believed. Meanwhile, the galaxy follows physical laws without concern for interpretation. Gas decreases, star formation declines. Time advances. You pass through a region that once hosted extraordinary stellar creation. Billions of years earlier, dense molecular clouds crowded this section of the disk. New stars formed continuously. Brilliant clusters illuminated the surrounding darkness. Now much of that activity has faded. The stars born during those productive eras still shine. But relatively few new stars join them. The difference feels almost emotional, despite being entirely natural. Like walking through an old neighborhood where the buildings remain, but the construction crews have long departed. The history is visible everywhere. The future is quieter. You begin noticing another important consequence. The galaxy's appearance changes more slowly than its underlying reality. To an outside observer, the galaxy still looks magnificent. Spiral arms remain visible. Countless stars continue shining. The structure remains intact, yet beneath that beauty, renewal is weakening. This disconnect between appearance and condition is common throughout nature. A tree may appear healthy long before hidden decay becomes visible. A city may seem prosperous while resources quietly diminish. A galaxy may sparkle brilliantly even as its star-forming future slips away. The universe often hides its transitions beneath continuity. You float near a giant molecular cloud that has survived for ages. Within its depths, gravity still works patiently. Some new stars will form here, not many, but some the galaxy has not stopped creating, it has merely slowed. That distinction matters. Death, in astronomy, rarely arrives as a single moment. Instead, it begins with reduced possibilities. The galaxy still possesses light, still possesses stars, still possesses beauty. What it increasingly lacks is potential. Potential for future generations, potential for large-scale renewal, potential for endless creation. And so the stellar nurseries grow quieter, one by one, region by region, epoch by epoch. The galaxy remains alive, but the balance is shifting. Creation no longer overwhelms consumption. The reservoirs that fueled billions of years of brilliance continue shrinking, and although countless stars still illuminate the darkness, fewer newborn suns rise to replace them. The great age of abundance is ending. The age of decline has begun. The galaxy does not notice its own aging, at least not in any conscious sense. It simply continues turning. Stars orbit the center as they always have. Nebulae drift through the spiral arms. Ancient clusters circle patiently through the darkness. And yet, when you step back far enough to see the whole picture, the transformation becomes unmistakable. The galaxy is changing color. Not dramatically, not overnight, but steadily. The brilliant blue stars that once dominated entire regions are becoming rarer. Their lives are short by stellar standards. Massive stars burn through their fuel quickly, sometimes lasting only a few million years. Compared to the Sun's expected lifetime of roughly 10 billion years, they are cosmic sprinters, fast, bright. Impressive, terrible at long-term survival. As fewer new stars form, fewer blue giants appear to replace those that die. The result is gradual but profound. Older stars begin taking over the skyline, and older stars tend to glow with softer, redder light. A mainstream scientific fact is that many aging galaxies become dominated by red giant stars and older stellar populations, giving them a noticeably redder appearance than younger, actively star-forming galaxies. From a distance, the galaxy starts to resemble an ancient city illuminated by warm lanterns rather than bright neon signs. Still beautiful, still alive, just different. You drift through one of the outer spiral arms. Billions of stars surround you. Many are older than entire civilizations could ever imagine. Some have been shining for billions of years. They witnessed the galaxy's energetic youth. They witnessed periods of intense star formation. Now they illuminate a quieter era. The atmosphere feels calmer somehow. Less frantic, less crowded. The galaxy is entering middle age. If galaxies had hobbies, this might be the stage where they suddenly become interested in gardening and discussing weather patterns. Nothing wrong with that. Just a different phase of life. You continue moving through the stellar disk. The reduction in star formation affects more than appearance. It changes the entire character of the galaxy. Fewer young stars mean fewer supernova explosions. Fewer supernovae mean less turbulence in the surrounding gas. The environment becomes increasingly stable. What was once dynamic and chaotic gradually becomes orderly. The galaxy begins settling down. Not because it chooses to, because it must. Its fuel supply no longer supports endless activity. You pass near a red giant star. It glows with a deep amber hue, swollen to enormous size compared with its earlier years. Stars like this become increasingly common. Many began their lives billions of years ago during the galaxy's golden age. Now they represent a growing share of the population. Their presence is a reminder of passing time. The galaxy carries its history within its stars. Every generation leaves traces behind. Every era remains visible to those who know where to look. A particularly fascinating historical fact comes to mind. When astronomers first began classifying galaxies in the early 20th century, they noticed significant differences in shape and color. Some galaxies appeared blue and active, others looked redder and more subdued. Over time, researchers realized these differences often reflected stages of galactic evolution. The color of a galaxy can reveal clues about its age and star-forming activity, a cosmic mood ring. Except several 100,000 light-years across, you glide past enormous globular clusters orbiting far above the galactic disk. These dense collections contain some of the oldest stars in the galaxy. Many formed early in its history. Some may be nearly as old as the galaxy itself. They resemble ancient archives drifting through space, silent records of distant eras. Unlike bustling stellar nurseries, these clusters feel timeless. The stars within them have been together for unimaginable spans of time, long before Earth existed, long before the sun formed, long before any human ever looked upward and wondered. A quirky tidbit from astronomy's past fits nicely here. For centuries, some observers believed globular clusters might be miniature galaxies of their own. Only later did improved observations reveal their true nature. The universe often hides scale behind distance. A small object nearby can seem larger than something vastly greater far away. It's one reason astronomy keeps surprising people and occasionally giving them headaches. The galaxy continues aging gracefully. Its spiral structure remains visible, but subtle changes accumulate. Dust lanes thin, star-forming regions become patchier. Certain arms lose some of their brightness. Nothing catastrophic occurs. No single event announces the transition. The galaxy simply grows older. Historians still argue whether ancient records describing unusual celestial appearances reflected genuine astronomical observations or symbolic storytelling. The debate continues because evidence can often support multiple interpretations. Astronomers face similar challenges when reconstructing galactic histories. They cannot watch billions of years unfold directly. Instead, they study clues, collars, chemical compositions, stellar populations, orbital patterns. The galaxy tells its story through evidence left behind. You drift toward the central regions. The density of stars increases dramatically. Here, countless suns crowd together. The galactic core glows with immense brightness. Yet even here, the changing demographics are apparent. Older stars dominate. Young blue stars appear less frequently. The balance continues shifting, one generation gradually replacing another. The process resembles a forest. Young saplings once emerged everywhere. Now mature trees dominate the landscape. The forest remains alive, but its age profile has changed. The same principle applies on scales measured in light years rather than meters. You begin noticing something else. The galaxy's future increasingly depends on stars already formed. Fewer new arrivals mean the existing population matters more. The stars currently shining will carry much of the galaxy's remaining story. And those stars are steadily aging as well, not quickly, not dramatically, but inevitably. Time never stops collecting its share. The galaxy still shines magnificently. Its redder glow possesses a quiet elegance, a mature beauty different from youthful brilliance. The frantic pace of creation has slowed. The stellar nurseries no longer dominate every corner of the disk. Instead, older generations illuminate the darkness with steady light. The galaxy has not died, not even close, but the transformation is undeniable. Its youthful blue radiance is fading, its red population grows, its future contains fewer births and more memories. And as billions more years pass beneath your drifting gaze, the galaxy becomes increasingly defined, not by the stars it creates, but by the stars it has already made. The galaxy grows quieter, not silent. A galaxy containing hundreds of billions of stars never truly becomes silent. But the noise changes. The frantic energy of constant creation begins giving way to something older, steadier, and far more mysterious. At the center of it all, hidden behind enormous curtains of dust and stars, Something awakens, the supermassive black hole. You drift toward the galactic core. The density of stars increases until the night sky would no longer resemble darkness at all. Countless suns crowd every direction. Distances that seem vast elsewhere become surprisingly compact here, and deep in the center waits an object so strange that even modern physics still wrestles with its full implications. The black hole has been there for ages, perhaps since the galaxy's earliest history, perhaps formed through mergers of smaller black holes, perhaps grown from massive ancient stars. Astronomers continue investigating exactly how the largest supermassive black holes reached their enormous sizes so quickly in the young universe. The details remain one of astronomy's great puzzles. Historians still argue whether certain ancient myths describing cosmic mouths, celestial voids, or devouring darkness reflected observations of the heavens or purely symbolic storytelling. The evidence remains open to interpretation, much like some mysteries surrounding black hole formation. You move closer, not too close. This is still a bedtime story, not a survival guide. A mainstream scientific fact is that nearly every large galaxy observed appears to host a supermassive black hole at its center. Some contain millions of solar masses, others contain billions. The Milky Way's own central black hole contains roughly 4 million times the mass of the Sun. Remarkably, despite their immense masses, black holes can remain relatively quiet for long periods. They do not constantly consume everything nearby. Popular movies have not always been entirely fair to them. If black holes had public relations departments, they would be filing complaints. For billions of years, the black hole at the galaxy's center may have remained comparatively calm. But conditions change. Gas drifts inward. Stars pass nearby. Matter accumulates. Eventually, feeding begins. And when a supermassive black hole becomes active, the results can influence an entire galaxy. You watch as enormous quantities of gas spiral inward. The material forms an accretion disk around the black hole. Friction heats the gas to extraordinary temperatures. Radiation erupts outward. The surrounding region becomes one of the brightest environments in the universe. Ironically, the black hole itself remains invisible. The spectacle comes from matter falling toward it. A cosmic traffic jam with truly spectacular consequences. The brightness is staggering. Some active galactic nuclei outshine every star in their host galaxy combined. Imagine a single object becoming brighter than hundreds of billions of stars. That tends to attract attention, even on cosmic scales. You drift safely beyond the chaos and observe immense jets blasting outward from the galactic center. These streams of energetic particles travel for thousands or even millions of light years. They punch through surrounding gas. They heat the galaxy's environment. They alter conditions far from the central black hole itself. This is where the story becomes especially important. The black hole does not merely consume matter, it can help regulate the future of the entire galaxy. The radiation and jets generated during active phases may heat cold gas reservoirs, and heated gas struggles to collapse into new stars. In other words, the black hole may contribute to shutting down future star formation. The galaxy's aging process accelerates, not through destruction. Through prevention, fewer stellar nurseries form, less cold gas survives. Fewer young stars are born. The effect resembles turning off the irrigation system in a vast garden. The plants already growing remain, but fewer new ones appear. A quirky tidbit from astronomy involves quasars, some of the brightest known objects in the universe. When quasars were first discovered, astronomers were baffled. Their light appeared star-like, yet their energy output was astonishingly large. For a time, researchers debated their true nature. Today, we understand that many quasars are powered by actively feeding supermassive black holes. The solution turned out to be even stranger than many of the original theories. The universe occasionally rewards curiosity with additional confusion. You continue observing the galactic center. The black hole grows, not quickly by human standards, but steadily across immense stretches of time. Each passing era adds mass. Each feeding event leaves consequences. The galaxy remains beautiful. Yet subtle transformations continue spreading outward from the core. Regions rich in cool gas become warmer. Star formation slows further. The population of young blue stars declines. The red glow of older generation becomes increasingly dominant. What makes this stage fascinating is that the galaxy still appears alive to most observers. Stars continue shining. Planets continue orbiting. Entire civilizations could potentially emerge and flourish during this period. Life inside the galaxy may never notice the larger transition underway. From their perspective, the cosmos remains grand and stable. Only from your distant vantage point does the pattern become obvious. The black hole is helping reshape the future, not through violence alone, through influence, through feedback, through subtle alterations that accumulate over billions of years. The galaxy's fate increasingly depends on processes unfolding in its heart. And yet even now, the black hole is not the sole actor. Gravity continues moving stars. Dark matter continues shaping structure. Gas continues flowing through the system. Countless mechanisms interact simultaneously. The universe rarely relies on a single cause. Instead, it prefers enormous networks of interconnected effects. One change leads to another, then another, then another. The galaxy ages not because one thing goes wrong, but because many small processes gradually push in the same direction. The stellar nurseries weaken. The central black hole influences its surroundings. The supply of fresh gas diminishes. The youthful era slips further into the past. Still, the galaxy endures. Its stars continue illuminating vast distances. Its spiral arms remain visible. Its ancient clusters continue orbiting patiently through the darkness. Yet beneath that enduring beauty, the balance is changing. The black hole has moved from background character to central influence. And as billions more years unfold, its growing power will help determine how quickly the galaxy approaches the long twilight that awaits every great island of stars. The galaxy has spent billions of years aging quietly. Its stellar nurseries have become less productive. Its youthful blue stars appear less frequently. Its central black hole has begun shaping the future in subtle but important ways. And then gravity decides to complicate everything again. You drift far beyond the galaxy's spiral arms, out into the vast darkness between galaxies. At first, the emptiness feels immense. Yet the universe is not nearly as isolated as it appears. Galaxies rarely live completely alone. They belong to groups, clusters, and larger cosmic structures connected by gravity across unimaginable distances. And gravity is patient, very patient. A neighboring galaxy slowly approaches, not quickly, not dramatically. No alarms sound. No cosmic announcer shouts warnings through space. The approaching galaxy advances at a pace that would make continental drift seem impatient. Still, over hundreds of millions and billions of years, the distance steadily shrinks. A mainstream scientific fact is that galaxy collisions are surprisingly common throughout cosmic history. In fact, many large galaxies owe much of their present size and structure to past mergers with smaller companions. You watch the two galaxies draw closer. At first, little changes. Each continues spinning through space. Stars maintain their orbits. The galaxies resemble enormous islands, slowly drifting toward one another across a dark cosmic ocean. Then the gravitational effects begin. The outer edges feel the pull. First, stars deviate slightly from previous paths. Gas clouds stretch. Tidal forces distort the spiral arms. Long streams of stars begin extending outward like luminous ribbons. The galaxies are not yet colliding. They are already interacting. Gravity works ahead of schedule, always eager to start the project early. You move closer as the encounter develops. The sight is breathtaking. Entire spiral arms twist and stretch. Massive arcs of stars curve across hundreds of thousands of light-years. Clouds of gas collide. Shockwaves ripple through interstellar space. The once orderly appearance of both galaxies begins dissolving into chaos. Yet something surprising happens. Very few stars actually collide. Individual stars are separated by enormous distances. Even during galactic mergers, direct stellar impacts remain relatively rare. A galaxy collision is less like two solid objects crashing together and more like two swarms of fireflies passing through one another, extremely dramatic from afar, unexpectedly spacious up close. A quirky astronomical tidbit highlights this beautifully. When people first hear galaxy collision, many imagine stars smashing together everywhere. In reality, a person living on a planet inside one of the galaxies might never witness a nearby stellar collision at all. The greatest changes come from gravity, not impact. The universe loves misleading terminology. You continue observing as gas clouds from both galaxies interact. Here, collisions become much more common. Unlike stars, vast gas reservoirs can slam together directly. Compression increases. Shockwaves spread, new regions of star formation ignite. Suddenly, the aging galaxy experiences something unexpected, a temporary revival. The merger triggers a burst of stellar creation. Massive clouds collapse. Countless new stars ignite. Entire regions blaze with fresh blue light. For a brief period, the galaxy looks younger than it has in ages. The effect resembles a city undergoing a huge construction boom after decades of slower growth. New lights appear everywhere, activity surges, excitement returns. Yet beneath the spectacle lies a hidden cost. The starburst consumes enormous quantities of remaining gas. The galaxy is spending its reserves at an extraordinary rate. A beautiful celebration, an expensive one. You watch as giant stellar nurseries illuminate the merging system. Young blue stars appear in great numbers. Clusters form, nebulae expand. The galaxy shines brilliantly. For a moment, it almost seems as though aging has been reversed. But only almost. The renewed activity accelerates future depletion. More stars mean more fuel consumed, more stellar winds, more radiation, more disruption of remaining gas supplies. The galaxy is borrowing brightness from tomorrow. Historians still argue whether certain ancient reports of unusual celestial objects reflected observations of galaxies, comets, supernovae, or atmospheric phenomena. Interpreting historical records remains challenging because descriptions often leave room for multiple explanations. Astronomers face similar challenges when reconstructing ancient galactic mergers. They examine stellar streams, chemical signatures, and orbital patterns left behind by long-vanished collisions. The evidence survives even after the event itself has faded into history. The two galaxies continue passing through one another. Then gravity pulls them back together. Again and again. Each encounter strips away more structure. The elegant spiral arms become increasingly distorted. Ordered rotation gives way to turbulence. The original identities of both galaxies begin dissolving. The process takes hundreds of millions of years. Patience remains mandatory. Fortunately, the universe has plenty of it. You drift above the merger as the galaxies complete another close pass. Their cores approach. Black holes move toward eventual interaction. Stars redistribute themselves throughout the growing system. The once distinct galaxies become increasingly difficult to separate. What began as two stellar cities is becoming one. The transformation is profound. Galactic collisions do not simply add material together. They reshape destiny. They alter future star formation. They reorganize stellar orbits. They change structure. They create entirely new galaxies from the remnants of old ones. And yet, despite all this activity, The merger does not save the aging galaxy from its long-term fate. The burst of creation remains temporary. The fuel remains finite. The underlying trend continues. The galaxy grows larger, brighter, more massive, but not younger. The clock keeps moving. As the collision unfolds across billions of years, one truth becomes increasingly clear. The galaxy's future will not be determined solely by internal aging. Its neighbors matter too. Gravity connects every major structure in the cosmos. No galaxy truly lives in isolation. And sometimes, the encounters that appear most destructive become the very events that shape the final chapters of a galaxy's life. The collision has changed everything. Not immediately, not completely, but permanently. You drift through the aftermath as billions of years continue flowing past. The once separate galaxies have become increasingly intertwined. Streams of stars stretch across enormous distances. Clouds of gas swirl through newly formed structures. The graceful order of the original spiral pattern has been deeply altered, yet gravity is not finished. Gravity is never finished. The larger galaxy begins absorbing what remains of its smaller companions. Astronomers sometimes call this process galactic cannibalism, which sounds considerably more alarming than it usually is. No giant cosmic teeth are involved, no galactic table manners are required, just gravity patiently rearranging matter over immense spans of time. A mainstream scientific fact is that many large galaxies grow by merging with and absorbing smaller satellite galaxies. Evidence for these ancient meals can still be found in stellar streams orbiting major galaxies today. You watch one small companion galaxy approaching from the darkness. Compared with the larger system, it appears modest, a few billion stars, perhaps several billion more, tiny by galactic standards, yet still incomprehensibly vast compared with anything familiar on Earth. The smaller galaxy falls inward. Its stars begin spreading out under tidal forces, its structure stretches, its identity weakens. Gradually, its stellar population becomes part of the larger galaxy. Individual stars continue existing. The galaxy itself does not. The distinction is important. Galactic death often involves transformation rather than destruction. The pieces survive, the original arrangement does not. You drift alongside a long stellar stream, left behind by one such merger. Millions of stars trace a graceful arc through space. They resemble glowing breadcrumbs marking the path of a vanished galaxy. To future astronomers, these streams become valuable clues, evidence preserved across billions of years, cosmic archaeology at its finest, no shovels required. Which is fortunate because digging holes in space tends to be impractical. The larger galaxy continues feeding on companions, one after another, not rapidly, not aggressively, just steadily. Each merger adds stars. Each merger adds dark matter. Each merger alters the galaxy's structure. For a while, growth continues. The galaxy becomes larger than ever before. Its stellar population expands. Its gravitational influence increases. Its reach extends farther into surrounding space. From a distance, this seems like success. The galaxy is gaining mass, gaining stars, gaining territory. But appearances can be misleading. The problem remains fuel. Most of the newly acquired material consists of stars already formed. What the galaxy truly needs is fresh, cold gas. And that resource becomes increasingly difficult to obtain. You observe one merger that initially appears promising. The smaller galaxy contains substantial gas reserves. As the systems interact, enormous clouds collide. New star formation erupts across multiple regions. Blue stars blaze into existence. Nebulae glow brilliantly. The galaxy experiences another temporary rejuvenation. A brief return of youthful energy, yet the pattern repeats. The starburst consumes fuel rapidly. The reserves shrink, the excitement fades. The long-term trend remains unchanged. Each celebration spends more of the future. A quirky astronomical tidbit comes from observations of the Milky Way itself. Researchers have discovered evidence that our own galaxy has consumed numerous smaller galaxies throughout its history. Some of their stars still travel together in recognizable streams. In a sense, portions of ancient galaxies continue orbiting the Milky Way today. Ghost neighborhoods from cities long absorbed, the universe rarely throws anything away completely. It prefers recycling. You continue drifting through the growing system. The galaxy now contains an astonishing variety of stellar populations, ancient stars from its earliest days, stars acquired through mergers, young stars formed during collision-triggered bursts, remnants of countless past generations. The galaxy carries the history of many smaller systems within itself. Like a library assembled from the contents of numerous vanished kingdoms, every star tells part of the story, every orbit preserves a clue. Historians still argue whether some ancient legends describing the absorption of one realm into another reflected historical events, symbolic teachings, or a combination of both. The surviving records often support multiple interpretations. Galaxies, in their own way, leave similar mysteries. The evidence survives. The exact sequence of events sometimes remains uncertain. Astronomers reconstruct the past from fragments, parns, structures, chemical fingerprints, orbital motions. The galaxy's biography is written across the sky. As billions more years pass, something important becomes clear. Cannibalism cannot continue forever. Eventually, nearby companions become scarce. Most suitable merger targets have already been absorbed. The surrounding environment grows quieter. The galaxy's growth slows, not because gravity weakens, because there is less remaining to acquire. The expansion phase begins ending. You move far above the galactic disk and look downward. The system appears enormous, larger than ever before, yet it also appears older. The bright star-forming regions occupy a smaller fraction of the whole. Redder stellar populations dominate increasing areas. The galaxy resembles an empire at the height of its territory, but beyond the peak of its vitality, still powerful, still magnificent, yet increasingly sustained by past achievements rather than future growth. The contrast is striking. For billions of years, mergers helped build the galaxy. Now those same mergers contribute to its aging. The additional stars increase mass but do little to solve the fundamental problem. Fresh fuel remains limited. Star formation continues slowing. The population continues maturing. The galaxy keeps accumulating history while losing possibility. And possibility, more than anything else, determines the future. You watch as another small companion dissolves into the larger structure. Its stars scatter, its shape disappears, its identity fades into a broader whole. The process is neither violent nor tragic. It is simply part of galactic evolution. A reminder that in the universe, survival often means becoming something new, yet even transformation has limits. The galaxy cannot consume its way back to youth. It cannot merge endlessly. It cannot manufacture infinite fuel. The resources that once supported boundless creation continue dwindling. And despite all the stars it gains, despite all the companions it absorbs, despite all the grandeur accumulated over billions of years, the galaxy moves steadily toward a future where growth no longer defines it. The feast continues, but the pantry grows emptier, and somewhere ahead in the darkness waits one final spectacular burst of creation before the long twilight deepens once again. The galaxy has consumed neighbors. It has survived collisions. It has reshaped itself through billions of years of mergers and gravitational encounters. And now, for one final glorious moment, it shines brighter than it has in ages. You drift above an immense region where vast clouds of gas are converging. The merger activity of previous eras has compressed enormous reservoirs of material. Shockwaves ripple through the interstellar medium. Gravity tightens its grip. Conditions become perfect for star formation. Not ordinary star formation, something much larger, a starburst. Across huge sections of the galaxy, stellar nurseries ignite almost simultaneously. Clouds collapse. New stars emerge by the millions. Entire regions blaze with fresh blue light. The aging galaxy experiences one last renaissance. A mainstream scientific fact is that starburst galaxies can produce stars at rates dozens or even hundreds of times greater than more typical galaxies. These bursts can dramatically alter a galaxy's appearance and evolution. From your vantage, the transformation is astonishing. Arges that had grown relatively quiet suddenly awaken. Nebulae glow intensely. Massive young stars illuminate surrounding gas. Clusters form in extraordinary numbers. The galaxy appears energized, rejuvenated, almost youthful again. If galaxies could throw farewell parties, this would be one of the greatest celebrations in the universe. And like many farewell parties, it is expensive, very expensive. The fuel consumption rate becomes enormous. The galaxy burns through reserves accumulated over billions of years. Gas that might have supported star formation for a long future instead disappears in a comparatively brief cosmic episode. The brilliance comes with a cost. You travel through one of the giant star-forming complexes. The scenery is spectacular. Decent clouds stretch across hundreds of light years. Young stars shine with intense blue-white light. Powerful ultraviolet radiation sculpts pillars and cavities within surrounding gas. Everywhere you look, creation is underway. The region resembles a cosmic fireworks display frozen in slow motion. Without the loud noises, which is helpful, this is still supposed to be relaxing. Among the newborn stars are many massive giants. These stars burn incredibly brightly. Unfortunately, they also burn incredibly briefly. Some will exhaust their fuel within only a few million years. Cosmically speaking, they arrive fashionably late and leave embarrassingly early. Their short lives contribute to the starburst's dramatic appearance. They provide enormous amounts of light. They also ensure the celebration cannot last. You continue observing as stellar winds sweep through the region. Radiation pressure pushes gas outward. Young stars begin disrupting the very clouds that created them. The process contains a strange irony. Star formation eventually suppresses further star formation. The newborn generation consumes and disperses the fuel needed by future generations. Success creates scarcity. The universe enjoys these little paradoxes. A quirky astronomical tidbit comes from some of the most extreme starburst galaxies ever observed. Certain systems become so active that they create stars at astonishing rates, producing entire stellar populations in relatively short periods. Researchers sometimes describe these events as cosmic fireworks factories, an unusually poetic phrase for scientific literature, though admittedly well-deserved. The galaxy continues glowing brilliantly. For a while, the renewed activity masks its underlying condition. An outside observer might believe the system has fully recovered. The blue stars are back. The nebulae are thriving. The stellar nurseries are active. Everything appears healthy, but appearances remain deceptive. The starburst is not a cure. It is a final expenditure. You float far above the galactic disk and observe the larger picture. The reserves are shrinking rapidly. Cold gas disappears. Deece's molecular clouds become less common. The galaxy is converting fuel into stars faster than ever before. No replenishment system exists capable of matching the demand. The celebration accelerates the future decline. Historians still argue whether some ancient societies interpreted brief periods of prosperity as signs of permanent renewal or temporary fortune. Historical records often reveal debates about whether great golden ages represented new beginnings or final peaks. The galaxy faces a similar question. Is this a rebirth, or a last flourish before decline deepens? From your perspective, the answer becomes increasingly clear. The starburst contains elements of both. It creates beauty. It produces new generations of stars. It briefly reverses visible signs of aging, yet it also hastens the exhaustion of remaining resources. The future grows shorter even as the present becomes brighter. You watch as some of the newly formed massive stars begin reaching the ends of their lives. Supernova explosions scatter heavy elements across surrounding space. The galaxy becomes enriched with the raw materials needed for planets and complex chemistry. Even in decline, creation continues leaving gifts behind. The cycle remains productive, just not sustainable. The starburst gradually weakens, not suddenly, not dramatically. The easiest fuel has already been consumed. The densest clouds have already collapsed. The most active regions begin quieting. The pace slows. Then slows again, and again. The galaxy starts settling after its extraordinary outpouring of activity. The difference becomes noticeable. Blue stars still shine everywhere, but fewer new ones join them. Nebulae remain visible, yet many are dispersing. The frenzy fades, the afterglow remains. You drift among clusters born during this final great era. Some contain thousands of stars, others contain millions. They will continue orbiting through the galaxy for immense spans of time, living monuments to the last major chapter of large-scale stellar creation. Future generations, if any observers remain to witness them, may look upon these stars and recognize them as products of the galaxy's final burst of youthful energy, a last great harvest, a final wave of possibility. And as the brightest regions slowly begin fading back into calmness, the reality becomes unavoidable. The galaxy has spent much of what remained. Its greatest celebration is ending. Its fuel reserves are lower than ever. Its future contains fewer opportunities for renewal. The light still shines brilliantly for now. But beyond that brilliance, beyond the clusters and nebulae and newborn stars, the long twilight waits patiently. And patience, as always, is one thing the universe possesses in endless supply. The fireworks have faded, not completely. The galaxy still sparkles with countless stars born during the great starburst. Blue giants illuminate pockets of lingering gas. Young clusters drift through space carrying the energy of recent creation. But the excitement is over. The galaxy settles once again into a quieter rhythm. And now, as the stellar celebrations recede into memory, you begin noticing a force that has been present throughout the entire story. A force you cannot see. A force that neither shines nor reflects light. A force that quietly shaped everything from the beginning. Dark matter. You drift far beyond the visible edge of the galaxy. The stars gradually thin, the glowing disk fades behind you. Eventually, the visible galaxy seems to end, yet gravity says otherwise. Stars near the outskirts continue orbiting faster than expected. Gas clouds move in ways visible matter alone cannot explain. Something larger surrounds the galaxy, something invisible. A mainstream scientific fact is that galaxies are embedded within enormous halos of dark matter. These halos contain far more mass than all the visible stars, planets, dust, and gas combined. The galaxy you have been watching lives inside one of these immense structures. Like a city built within an invisible continent, you cannot observe the dark matter directly. It emits no light. It reflects no light. It appears to interact primarily through gravity, yet its influence extends everywhere. Without it, galaxies as we know them might never have formed. You float through regions occupied almost entirely by this unseen framework. Nothing appears different. Space remains dark, stars remain distant, yet gravity quietly reveals the hidden architecture. The galaxy's visible components are only part of the story. Most of the mass lies beyond sight. The realization feels oddly humbling. Even after centuries of scientific progress, much of the universe remains mysterious. Dark matter may be one of the largest mysteries of all. researchers continue searching for its true nature. Various theories compete for attention. New experiments attempt to detect it. The puzzle remains unsolved, and perhaps that uncertainty makes the cosmos feel even larger. You observe how the dark matter halo extends far beyond the galaxy's luminous boundaries. The stars occupy only a relatively small central region. The invisible halo stretches much farther outward. Even as the galaxy ages, the halo remains. Even as star formation declines, the halo remains. Even as entire stellar populations evolve and disappear, the halo remains. Dark matter becomes a kind of silent caretaker, present through every chapter. A quirky tidbit from astronomy's history illustrates how surprising this discovery was. When astronomers first noticed unusual galactic rotation patterns, many suspected missing matter of some kind. Few anticipated that the invisible component would eventually prove so dominant. The universe once again revealed that reality was stranger than expected. A recurring theme, really. If the cosmos ever printed a slogan, it might simply read, "Surprise." You continue drifting along the outer reaches of the halo. The galaxy behind you appears older now. The bright star-forming regions occupy only small portions of the disk. Most visible stars belong to mature populations. The red glow dominates increasingly large areas. Yet despite these visible changes, the dark matter structure remains remarkably stable. It does not age in the same way stars do. It does not exhaust fuel. It does not require stellar nurseries. The contrast becomes fascinating. The visible galaxy experiences birth, maturity, and decline. The dark halo endures almost unchanged, like a stage that remains standing long after successive performances have ended. Historians still argue whether ancient philosophers who proposed unseen components of reality intended physical explanations, metaphors, or something in between. Their writings often allow multiple interpretations. Modern astronomers face a different challenge. They know something unseen exists. The debate concerns exactly what it is. Invisible matter, modified gravity, some entirely new phenomenon? The evidence strongly supports the existence of hidden mass, but its ultimate nature remains one of science's great open questions. Meanwhile, the galaxy continues aging. You watch stars orbit through gravitational pathways defined partly by the dark matter halo. Their motions remain orderly. Their trajectories remain stable. Without the halo's influence, many outer stars might move very differently. The galaxy's structure depends upon foundations it cannot directly observe. A curious lesson. Not all important things are visible. Not in galaxies, not in nature, perhaps not even in life. You continue examining the outskirts. The remaining gas reservoirs grow smaller. Star formation continues declining. The population ages further. The dark matter halo cannot create new stars. It cannot replenish fuel. It can only provide gravitational support. The invisible foundation remains strong while the visible city slowly grows old. There is something almost poetic about that. The framework survives, the details change. The same pattern appears throughout the universe. Planets form and disappear. Stars ignite and fade. Galaxies evolve. Yet underlying structures often persist across astonishing spans of time. The galaxy's future will still be shaped by its halo, even during the final stages, even after most star formation has ceased. Even when bright young stars become rare memories, the dark matter remains silent. Invisible past end, you turn once more toward the galaxy itself. The starburst generation continues shining brightly. For now, but those stars are already aging. The clock never stopped, the fuel never returned. The decline merely paused long enough to create one final display of brilliance. Now the long trend resumes. The galaxy still possesses hundreds of billions of stars. It still fills vast regions of space with light. Yet increasingly, it resembles an aging metropolis illuminated by old lamps rather than new construction. its foundations remain secure. Its future growth does not. And as the invisible halo continues holding everything together, the visible galaxy moves steadily toward its next great transformation, one that will alter its very shape and leave behind a calmer, older, and far more silent cosmic landscape. The galaxy no longer resembles its younger self. The transformation has taken billions upon billions of years, so slowly that no single generation of stars could fully appreciate it. Yet from your vantage point, drifting above the immense sweep of cosmic history, the change is unmistakable. The elegant spiral arms that once wrapped gracefully around the galactic disk are fading, not vanishing all at once, simply losing definition, losing purpose, losing the constant flow of new stars that once illuminated their structure. You watch as stellar orbits become increasingly randomized after countless mergers and gravitational encounters. The galaxy's orderly appearance begins softening. The neat architecture of youth gradually gives way to something broader and calmer, something older. A mainstream scientific fact is that many large elliptical galaxies are thought to form through mergers between spiral galaxies. These mergers disrupt organized stellar motion and can transform elegant spirals into more rounded systems. The process is surprisingly common throughout cosmic history. In many ways, becoming elliptical is one of the most typical destinies awaiting a mature galaxy. You drift high above the system. The once prominent spiral pattern appears increasingly difficult to identify. Stars no longer follow the same organized paths that characterized earlier eras. Instead, they travel in a wider variety of directions. The galaxy swells into a vast glowing cloud of ancient starlight. It still contains tremendous beauty, just a different kind. The youthful galaxy resembled a vibrant city full of construction cranes and bright new neighborhoods. The elliptical galaxy resembles an ancient capital, grand, massive, quite filled with history. And slightly resistant to change, the transformation feels almost dignified. There is no dramatic collapse, no catastrophic failure, simply a gradual rearrangement driven by gravity's relentless influence. Gravity never gets bored. If gravity had hobbies, its favorite pastime would probably be reorganizing furniture across entire galaxies. You continue observing as the galaxy settles into its new form. The bright blue stars that once highlighted spiral arms become increasingly scarce. Many have already completed their brief lives. The remaining population consists largely of older stars, yellow stars, orange stars, red giants, white dwarfs. The color palette changes. The galaxy glows with warm amber tones rather than youthful blue brilliance. A quirky tidbit from observational astronomy emerges here. Some of the largest elliptical galaxies ever discovered contain trillions of stars and rank among the most massive structures in the universe. Yet despite their enormous populations, many appear surprisingly calm compared with younger star-forming systems. Size does not necessarily mean activity. A lesson applicable in more places than astronomy. You drift through the outer regions. The environment feels different, not empty, not dead, just settled. Star-forming clouds have become rare. Massive nebulae appear infrequently. The dramatic visual spectacles of stellar birth no longer dominate the landscape. The galaxy spends more time preserving existing stars than creating new ones. It has entered a period of maintenance rather than expansion. Historians still argue whether certain ancient empires declined because of specific events or because long-term structural changes gradually reduced their ability to adapt. Often, the answer appears to involve both. Galaxies experience something similar. No single event causes this transformation. Mergers contribute, fuel depletion contributes, black hole activity contributes. Time contributes, many influences combine. The result emerges slowly. You approach the galactic center. The density remains astonishing. Countless stars fill every direction. Yet even here, signs of aging persist. The stellar population is mature, the brightest young stars are uncommon, ancient generations dominate the view, the galaxy increasingly resembles a museum of its own history. Every star records a chapter, every orbit preserves a memory. You float among stars that formed billions of years apart. Some emerged during the galaxy's youth, others arrived through mergers. Others formed during the final great starburst. Together they create a layered archive of cosmic time. The galaxy carries its entire biography within its structure. What strikes you most is the stability. The frantic activity of earlier eras has largely ended. The galaxy no longer changes rapidly. Its shape remains relatively constant. Its stellar population evolves gradually. Its future becomes more predictable. Aging often brings calm. In galaxies as well as people, though galaxies generally require fewer comfortable chairs and significantly larger living rooms. You move farther outward once again. The elliptical form now dominates the skyline. The old spiral identity survives only in scattered clues visible to careful observers, faint stellar streams, residual structures, orbital patterns left behind by ancient mergers. The past remains detectable, but it no longer defines the present. The galaxy has become something new, and yet this transformation does not represent the end, far from it. Hundreds of billions of stars continue shining. Many possess lifetimes extending far into the future. The galaxy still contains immense amounts of light, immense amounts of mass, immense amounts of history. Its story continues. Only the nature of the story has changed. Creation once dominated. Now endurance takes center stage. You watch as the galaxy drifts through another billion years, then another, and another. The overall appearance changes little. The structure remains stable. The stellar population grows incrementally older. The pace feels almost meditative. The universe settling into a long exhale, yet beneath this calm surface, a deeper transition is underway. The stars themselves are aging, one by one, generation by generation. The great factories of stellar creation have largely fallen silent. Future chapters will increasingly belong not to newborn suns, but to the remnants left behind when stars reach the ends of their lives. The galaxy has transformed from a bustling cradle of creation into a vast archive of accumulated starlight. Its spiral youth is gone. Its elliptical maturity has arrived, and waiting quietly ahead is an era when the dead will begin to outnumber the living among the stars. The galaxy has settled into maturity. Its spiral arms have faded into memory. Its major mergers are largely complete. Its star-forming regions have become scarce. From a distance, it appears stable, almost timeless. But stability is not the same as permanence. The stars themselves continue aging, and one by one, they leave behind something else, remnants. You drift through the galaxy as billions of years pass. The bright stars that once illuminated stellar nurseries begin reaching the ends of their lives. Massive stars disappear first. They always do. Their existence burns brilliantly, but briefly. After exhausting their fuel, they collapse and transform into exotic objects. Some become neutron stars, others become black holes. The exact outcome depends largely on their mass. Either way, the original star is gone. A mainstream scientific fact is that stars do not all die the same way. Smaller stars often become white dwarfs, while larger stars may end as neutron stars or black holes after catastrophic final stages. The galaxy begins accumulating these remnants, slowly at first, then increasingly quickly. Generation after generation contributes to the collection. The living stellar population remains enormous, yet the population of stellar corpses steadily grows. You pass near a white dwarf. At first glance, it seems unimpressive. A tiny point of light drifting through darkness. But appearances deceive. This object contains roughly the mass of a star, compressed into a volume comparable to Earth. Its matter exists in extraordinary conditions. A spoonful would weigh far beyond anything encountered in ordinary life. Fortunately, cosmic etiquette discourages carrying spoons into white dwarfs. You continue onward. White dwarfs become increasingly common. Most stars in the galaxy are relatively small. Many eventually end this way. Their outer layers drift into space. Their hot cores remain behind. These remnants cool gradually across trillions of years, not millions, not billions, trillions. The universe operates comfortably on timescales that make even galaxies seem temporary. Nearby, you observe another kind of remnant, a neutron star. The object appears tiny, yet its density is almost beyond imagination. Matter inside neutron stars is packed so tightly that atomic structures themselves collapse under immense pressure. The result is one of the strangest objects known to physics, a city-sized sphere containing more mass than the Sun. The universe occasionally seems determined to win every absurdity competition, and usually succeeds. The galaxy continues aging. More stars complete their lives. More remnants accumulate, the stellar graveyard expands, yet there is no sadness in the process. These remnants are not failures. They are natural outcomes, transformations. The matter remains, the energy remains. Only the form changes. Historians still argue whether ancient cultures viewed celestial cycles primarily as endings or renewals. Many traditions contain elements of both perspectives, making interpretation difficult. The universe itself seems to embrace both ideas simultaneously. Stars end. New stars once formed from their remains. Now, however, new star formation has become increasingly rare. The balance shifts. Death begins outpacing birth. You drift through a region populated largely by ancient stars. The difference is noticeable. The environment feels older, calmer, less dynamic. The brilliant blue giants that once dominated certain areas have long vanished. Their remnants remain. Their light does not. The galaxy increasingly becomes a place where symmetry outweighs novelty. A quirky astronomical tidbit emerges as you travel. Some neutron stars rotate hundreds of times per second, emitting beams of radiation that sweep across space like lighthouse beams. These objects, known as pulsars, can be so precise that astronomers sometimes compare them to cosmic clocks. Imagine a dead star outperforming many watches. Not bad for retirement. You continue deeper into the galaxy. White dwarfs multiply, neutron stars multiply, black holes multiply. The cumulative effect becomes significant. Entire populations of stellar remnants now occupy the system. Many are difficult to detect. Some emit little or no light, yet their gravity remains. Their influence persists. The visible galaxy begins hiding more and more of its mass within these ancient objects. You encounter a region once famous for vigorous star formation. Billions of years earlier, nebulae glowed brightly here. Young clusters filled the sky. New suns emerged continuously. Now the scene feels entirely different. The stars remain, but most are old. The gas clouds are largely gone. The stellar nurseries have fallen silent. The contrast is striking. A cosmic neighborhood transformed by time, and time continues moving, always moving. The galaxy no longer relies upon creation for its identity. It relies upon endurance. The stars that remain must carry the story forward. Many are long-lived red dwarfs. These small stars consume fuel slowly and can survive for astonishing durations. Some may continue shining for trillions of years, long after larger stars have vanished, long after civilizations have disappeared, long after the galaxy itself has changed beyond recognition. The smallest stars often prove the most patient, a lesson with surprisingly broad applications. You drift toward the galactic core. The supermassive black hole still resides there, larger than before, heavier than before waiting. Around it orbit countless stars, remnants, and compact objects. The center resembles a crowded archive of accumulated history. Every era contributes something. Nothing truly disappears. The galaxy carries all its previous chapters forward. Yet the ratio continues shifting. More remnants, fewer newborn stars, more memories, fewer beginnings. The transition happens so gradually that no single moment marks the change. Still, the trend is unmistakable. The dead increasingly outnumber the newly born. White dwarfs fill the darkness. Neutron stars pulse quietly through space. Black holes drift unseen among ancient stellar populations. The galaxy remains bright. But underneath that glow, another reality emerges. Its future belongs increasingly to survivors rather than successors. The age of stellar remnants has arrived. And as the last significant generations of stars continue aging, the galaxy begins moving toward an even stranger future. One where gravity itself will slowly start emptying the great stellar city it spent billions of years building. The galaxy still contains hundreds of billions of stars. That number alone makes it seem immortal. How could something so vast ever truly fade? How could a structure assembled across billions of years possibly come apart? The answer, as usual, is patience. Gravity built the galaxy. And over unimaginably long timescales, gravity will also help dismantle it. You drift through an ancient stellar population. The galaxy appears calm, stable, almost frozen in time. Yet beneath this peaceful appearance, countless gravitational interactions continue unfolding. Every star influences every other star. Not strongly in most cases, not dramatically. Just enough. A mainstream scientific fact is that stars passing near one another can exchange energy through gravitational interactions. Over enormous periods, these encounters gradually alter stellar orbits throughout a galaxy. One encounter means little. 1,000,000 encounters begin to matter. 1,000,000,000,000 encounters become destiny. You watch as two stars pass relatively close to each other. Nothing spectacular happens, no collision, no explosion, no dramatic soundtrack. The stars simply exchange a tiny amount of orbital energy, then continue on their separate journeys. The change is almost imperceptible. But the galaxy contains billions upon billions of stars. Tiny effects accumulate, tiny changes compound. The universe excels at compound interest. Given enough time, even the smallest adjustments reshape entire systems. You continue drifting through the galaxy's outer regions. Some stars now travel slightly faster than before, others move along altered paths. A few acquire enough energy to escape entirely. These stars become cosmic runaways. They leave the galaxy behind, forever. The process resembles individual citizens, quietly moving away from a city over many generations. One departure means nothing. Millions eventually transform the population. You watch one such star beginning its escape. For billions of years it orbited comfortably within the galaxy. Now its trajectory carries it outward, farther, farther still. Eventually, the galaxy's gravitational pull weakens enough that return becomes impossible. The star enters intergalactic space, a lonely traveler crossing immense darkness. No dramatic farewell ceremony accompanies its departure. The galaxy barely notices, yet departures continue, again and again and again. A quirky astronomical tidbit highlights just how strange this can become. Astronomers have discovered stars moving fast enough to escape their host galaxies entirely. Some may have been accelerated by encounters with supermassive black holes. Imagine receiving directions so aggressively that you leave the entire galaxy. Not exactly subtle navigation. You drift alongside one escaping star. The view changes gradually. The galaxy shrinks behind you. Its glow becomes smaller, dimmer, more distant. The star carries its own history into the darkness. A tiny piece of the galaxy permanently removed. Over trillions of years, countless similar departures occur. The cumulative effect becomes significant. The galaxy slowly loses population. not because stars are dying faster, not because of collisions, simply because gravitational interactions redistribute energy. The stellar city begins emptying. Historians still argue whether certain ancient cities declined primarily because of external pressures or because residents gradually left over time. In many cases, the answer appears to involve both. Galaxies experience something similar. Multiple processes operate simultaneously. Stars die, remnants accumulate, and now stars begin leaving altogether. No single cause explains the decline. The galaxy ages through countless small changes working together. You return toward the denser regions. Here, interactions occur more frequently. The crowded environment increases opportunities for gravitational encounters. Over immense timescales, stars exchange energy continuously. Some sink inward, others move outward. The overall structure slowly evolves. The process is sometimes called dynamical relaxation, a remarkably calm name for something that eventually empties entire regions of a galaxy. Scientists occasionally display admirable restraint when naming things. You continue watching as stellar population redistribute themselves. The galaxy's appearance changes only gradually. An observer living for a few billion years might barely notice. Fortunately, you possess the narrative advantage of witnessing epochs unfold like pages in a book. From your perspective, the trend becomes clear. The galaxy is leaking, not gas this time, not fuel. Stars, one by one, gestation by generation. The losses accumulate. The galaxy remains enormous. Yet it is no longer preserving everything it created. Some of its stars now belong to the darkness between galaxies. You drift beyond the outskirts once more. Intergalactic space feels vast beyond description. The escaping stars become isolated points of light, separated by immense distances. Each represents a former resident. Each carries evidence of the galaxy's past. The city spreads outward into the void, not through expansion, through dispersal. There is something strangely peaceful about it. No catastrophe, no violence. Just gradual release. The universe rarely rushes its endings. You observe another consequence. As stars leave, the remaining population becomes increasingly dominated by compact remnants and long-lived survivors. The galaxy's demographics continue shifting. Red dwarfs persist, white dwarfs cool, neutron stars endure. Black holes drift silently through the darkness. The bright, short-lived stars that once defined the galaxy are mostly gone. The future belongs to patience and to objects that specialize in it. You turn back toward the galaxy. Its glow remains impressive, yet compared with earlier ages, it appears thinner, older, less crowded. The changes remain subtle but cumulative. Billions of years built this stellar metropolis. Trillions will slowly dismantle it. The process has already begun. Stars continue escaping. The population continues aging. The structure continues evolving. And somewhere ahead lies an era when even the survivors, the black holes, neutron stars, and white dwarfs, will inherit a universe growing darker with every passing age. The galaxy is no longer a kingdom of young stars. Those brilliant blue giants that once illuminated entire spiral arms have mostly vanished into history. Their brief lives ended ages ago. The stellar nurseries that once replaced them have largely fallen silent. Now the survivors inherit the future, and among all the survivors, none are stranger than black holes. You drift through a galaxy that has already lost much of its youthful energy. The population continues thinning. Stars escape into intergalactic space. White dwarfs cool slowly. Neutron stars persist like cosmic fossils, yet black holes become increasingly important. Not because they suddenly appear, because they remain. A mainstream scientific fact is that black holes can survive for extraordinarily long periods of time. In many models of the far future universe, they outlast ordinary stars by unimaginable margins. Patience, once again, proves valuable. The universe rewards endurance, and black holes are endurance specialists. You move through a region populated by ancient stellar remnants. Many stars that once shone here have completed their life cycles. Their descendants remain, some as white dwarfs, some as neutron stars, some as black holes drifting invisibly through the darkness. The galaxy still exists, but increasingly, much of its important mass resides in objects that emit little or no light. The visible universe slowly becomes less visible. A curious design choice. If you think about it, you drift toward one stellar mass black hole. Nothing marks its position directly. No glowing sign hovers nearby. No helpful cosmic label announces, "Black hole, please do not touch." Instead, you infer its presence through gravity. Nearby objects orbit an unseen center. Matter curves around invisible influence. The black hole reveals itself indirectly, just as it always has. A quirky tidbit from the history of astronomy fits perfectly here. For centuries, the idea of objects so massive that light could not escape seemed almost absurd. Early thinkers proposed similar concepts long before modern physics existed, but many people regarded them as mathematical curiosities rather than physical realities. Reality eventually proved stranger than skepticism. Again, the universe maintains a remarkably consistent track record in that department. You continue drifting through billions of years. The galaxy grows dimmer, not dramatically. Gradually, the brightest stars disappear. Long-lived red dwarfs dominate much of the remaining stellar population. These tiny stars burn fuel so slowly that some may survive for trillions of years. Compared with larger stars, they are masters of efficiency, the cosmic equivalent of a vehicle that somehow drives forever on half a tank. You pass near several ancient red dwarfs. Their light feels gentle, steady, unhurried. They continue shining while countless larger stars have already vanished. Yet even these patient survivors will not last forever. The clock continues moving, always. You return your attention to the black holes. As stellar populations age, encounters occasionally bring compact remnants together. White dwarfs interact, neutron stars interact, black holes interact. Some merge. The process unfolds across enormous timescales. Each merger creates a larger black hole, a larger survivor. The galaxy gradually concentrates part of its mass into fewer, heavier objects. Gravity continues simplifying the population, not intentionally, just inevitably. Historians still argue whether some ancient civilizations viewed time as a cycle or as a one-way journey toward an ultimate destination. Different traditions offered different answers, and scholars continue debating interpretations. The universe seems to provide elements of both. Cycles exist. Stars form and die. Matter recycles. Yet large-scale evolution also moves forward. The galaxy cannot return to youth. The path leads onward. You watch as a pair of black holes orbit one another. Their dance lasts ages. Eventually, gravitational waves carry energy away. The orbit shrinks. The black holes spiral closer, closer, closer still, then they merge. The event sends ripples through space-time itself. A larger black hole remains. The galaxy loses another separate object. Gains another survivor. The balance shifts once again. Across trillions of years, countless similar interactions occur. The stellar population continues declining. The remnant population continues evolving. Black holes become increasingly prominent simply because they refuse to leave the story. Everyone else exits earlier. You drift far above the galaxy. Its appearance has changed dramatically compared with the vibrant spiral system you first encountered. The bright regions are gone. The giant stellar nurseries are memories. The great starbursts have faded. The galaxy resembles a quiet archive illuminated by scattered survivors. Yet hidden within that darkness are growing numbers of black holes, silent custodians of accumulated mass. You observe another long-term trend. Many stars have already escaped. Others have died. The overall population decreases. the galaxy becomes less crowded, less luminous, more diffuse. The city continues emptying, and the remaining residents increasingly belong to the realm of remnants, white dwarfs, neutron stars, black holes. The future demographics are unmistakable. The living no longer dominate, the survivors do. You continue forward through unimaginable stretches of time. The last ordinary stars become rarer. The darkness between remaining lights grows larger. The galaxy begins resembling a collection of isolated relics rather than a bustling stellar civilization, yet black holes remain large ones. Small ones, merged ones, ancient ones. They drift through the fading structure like shadows that have outlived the objects casting them. There is something strangely fitting about this. Black holes spent much of cosmic history as supporting characters. Now they inherit the stage, not through conquest, not through aggression, through persistence. The galaxy's decline has elevated the most durable objects to positions of importance. And as the remaining stars continue disappearing across the far future, the balance tilts further still. The era of starlight approaches its end, the era of darkness approaches its beginning, and waiting beyond the fading glow lies a future in which the galaxy itself may eventually lose not only its youth, not only its stars, but even its identity as a recognizable galaxy at all. The galaxy has become difficult to recognize. If you could somehow compare this distant future with the brilliant spiral system from billions and trillions of years earlier, the difference would feel almost impossible to believe. The crowded stellar avenues are gone, the giant nebulae have vanished. The blue stars that once lit entire regions disappeared ages ago. Even many of the long-lived red dwarfs have finally exhausted their fuel. The galaxy still exists, but only in the loosest sense of the word. You drift through a realm populated mostly by remnants. White dwarfs, neutron stars, black holes, scattered survivors orbiting through an increasingly empty darkness. A mainstream scientific fact is that over sufficiently long timescales, gravitational interactions can continue dispersing stars and remnants from galaxies, gradually reducing their coherence as recognizable structures. The process never needed explosions. It never required a final catastrophe. The galaxy simply keeps unraveling. One object at a time, you watch a lonely white dwarf drifting through space. Long ago it was a normal star. Long before that, it formed inside one of the galaxy's ancient stellar nurseries. Now it glows faintly, steadily losing heat accumulated across countless ages. Its story mirrors the galaxy itself. Brilliant beginnings, long endurance, gradual fading. The white dwarf continues cooling. Eventually it becomes dimmer still, and dimmer and dimmer. The universe increasingly resembles a place where memories outnumber active participants. You travel farther outward. The distances between objects become astonishing, even by cosmic standards. Many stars have escaped, many remnants have migrated. The once dense stellar population has spread across enormous volumes of space. The galaxy's boundaries blur, its structure weakens, its identity begins dissolving. A quirky astronomical tidbit emerges here. Some researchers have explored the possibility that future observers, if any existed in these unimaginably distant eras, might struggle to reconstruct the history of galaxies because so much evidence would have dispersed across vast distances. Cosmic archaeology becomes increasingly difficult when the ruins themselves drift away. You continue observing. The supermassive black hole remains near the center, or what used to be the center. The distinction matters less now. The surrounding structure has thinned dramatically. Many of the objects once orbiting nearby are gone. Others occupy altered trajectories. The galaxy's original architecture survives mostly as a historical concept. Gravity continues reshaping everything, slowly, relentlessly, painfully. Historians still argue whether certain ancient civilizations disappeared suddenly or gradually transformed into something else over generations. Often, what appears to be an ending from one perspective becomes a transformation from another. Galaxies follow a similar pattern. Has the galaxy died? Or has it merely changed beyond recognition? The answer depends partly on definitions. The stars remain. Some remnants remain. The black holes remain. Yet the organized system that once defined the galaxy continues fading. Its identity unravels. You drift through regions where isolated objects travel enormous distances from one another. The night sky, if one could stand on a surviving world, would appear very different. Fewer stars, greater darkness, larger empty spaces. The universe feels older, not merely in age, in atmosphere. The energy of youth has long departed. Even the calm maturity of earlier eras seems distant now. This is old age on a cosmic scale. You encounter a pair of black holes orbiting one another. Their dance lasts for ages. Eventually they merge, creating a larger remnant. The process repeats throughout the galaxy. Smaller populations become larger individual survivors. The number of objects declines. The average mass of survivors increases. The galaxy simplifies itself. Not intentionally, just statistically, the future favors endurance. You move across millions of years, then billions, then trillions. The remaining structure continues weakening. The galaxy's once clear outline disappears. No observer looking from afar would see the majestic spiral of ancient times, nor the massive elliptical giant of Middle Age. Instead, they would see scattered remnants occupying a broad region of space, a former galaxy, a memory distributed across the darkness. The transformation feels surprisingly gentle. No final explosion marks the occasion. No cosmic curtain drops. No grand farewell speech arrives. The galaxy simply ceases to be a recognizable galaxy. Its components survive, its identity does not. There is something profound about that distinction. The universe often preserves matter while dissolving patterns. The atoms remain. The arrangement changes. The same truth applies to stars, to galaxies, perhaps even to many things closer to home. You continue drifting through the increasingly empty future. Black holes dominate much of the remaining mass. White dwarfs cool further. Neutron stars persist quietly. The surviving population becomes smaller and more isolated. Interactions grow rarer, distances grow larger, darkness grows deeper. The galaxy's long story approaches its final pages, not because every object has vanished, because the structure itself no longer holds together as it once did. The city has emptied. The neighborhoods have dispersed. The roads have faded. Only scattered monuments remain, and beyond those monuments lies an even stranger future, one in which the surviving black holes themselves may eventually become the primary inhabitants of an ancient universe moving steadily toward endless night. The galaxy is gone. Not gone in the sense of disappearing completely, not gone in the sense of being destroyed by some spectacular cosmic disaster, gone in a quieter way. The organized structure that once contained hundreds of billions of stars has unraveled. Its spiral arms vanished ages ago. Its elliptical form dissolved over immense stretches of time. Its stars escaped, cooled, died, or transformed. The galaxy no longer exists as a recognizable galaxy. Only remnants remain. You drift through a universe older than anything the early cosmos could have imagined. Around you, darkness dominates. Scattered black holes drift through immense expanses of space. Ancient white dwarfs have cooled toward invisibility. Neutron stars persist as silent relics. The great age of starlight has largely ended. A mainstream scientific fact is that many theoretical models of the far future universe predict a gradual decline of luminous objects as stars exhaust their fuel, and no significant new star formation remains possible. The cosmos becomes quieter, not empty, just quieter. You float through distances so vast that language struggles to describe them. The remnants of countless former galaxies occupy isolated regions separated by extraordinary gulfs of darkness. Each remnant carries traces of ancient histories. Each black hole contains records of long-forgotten stellar generations. Each surviving object represents a chapter that refused to vanish completely. The universe has become a library after closing time. The books remain, the readers are gone. A quirky tidbit from theoretical physics appears here. Some calculations suggest that black holes themselves may not last forever. Through a process known as Hawking radiation, they could slowly lose energy across inconceivably long periods. The timescales involved are so enormous that even writing them feels almost absurd. Trillions upon trillions of years. Numbers become scenery rather than measurements. You observe one of these ancient black holes. It has survived longer than entire eras of cosmic history. Longer than stars. Longer than galaxies. Longer than civilizations could meaningfully imagine. Yet even it is not eternal. Its future contains change. The universe remains committed to transformation. No exceptions, historians still argue whether ancient thinkers viewed eternity as endless duration or as something existing outside time altogether. The debate persisted across cultures and centuries because the concept itself resists easy definition. The universe seems to offer its own answer. Endless duration is surprisingly difficult to achieve. Everything changes eventually. Everything evolves. Everything participates in the long flow of time, even galaxies, even black holes, even the structures that once seemed permanent. You continue drifting through the darkness. The last recognizable traces of the galaxy are scattered across unimaginable distances. A lone white dwarf here, a wandering neutron star there, an ancient black hole farther away. The original arrangement is gone, the components survive. For a while, the distinction that has followed us throughout this journey appears once again. Death in the universe rarely means annihilation. It means transformation. The galaxy died not when its stars vanished, not when its spiral arms disappeared, not when its star formation ended. The galaxy died when it ceased being itself. Its matter remained, its identity did not. You watch the darkness stretching endlessly in every direction, yet the scene feels oddly peaceful. No violence remains. No collisions, no starbursts, no frantic creation. The universe has settled into profound stillness, a vast cosmic evening after an extraordinarily long day. The stars that once illuminated entire galaxies have completed their stories. The galaxies that once filled clusters have changed beyond recognition. The universe itself seems to breathe more slowly. And now, as our journey nears its end, the pace softens further. The darkness no longer feels threatening, it feels calm, gentle, like a quiet ocean beneath a moonless sky. You drift without destination, without urgency, without clocks. The remnants of ancient galaxies shimmer faintly in the distance, each one carrying echoes of a brighter past. Somewhere, long ago, spiral arms once glowed with newborn stars. Nebulae blossomed across enormous clouds of gas. Supernovae illuminated entire regions of space. Black holes fed at galactic centers. Collisions reshaped cosmic architecture. Civilizations may have gazed upward and wondered. All of it happened, all of it mattered, and all of it became part of a larger story. The story never truly ended. It simply changed form. The matter remains in new arrangements. The energy continues its journey. The universe moves forward. Slowly, partly, quietly. As you drift through this ancient future, the darkness becomes softer. The distances feel less overwhelming. The silence feels less empty. You simply float, watching, listening, existing within a cosmos that has spent ages transforming itself. The galaxy you followed from birth to death has completed its journey, from chaotic clouds to radiant spirals, from bustling star factories to aging red populations. From collisions and mergers to quiet decline, from recognizable structure to scattered remnants, a full life on a scale almost impossible to comprehend. And now there is only stillness, a gentle cosmic twilight stretching beyond sight, the last lights fading gradually into the immense calm of the far future, nothing rushed, nothing forced. Only the slow unfolding of time, the soft persistence of existence, the quiet reminder that even the grandest structures in the universe are part of a larger flow. So as the darkness settles around those ancient remnants, and as the final echoes of long-dead galaxies drift through the vastness, you can simply rest here for a moment. The universe is old, the journey is complete, and the night is peaceful. End of script. Sweet dreams.